Oxygen first accumulated in the Earth's atmosphere about 2.4 billion years ago, during the Great Oxidation Event. A long-standing puzzle has been that geologic clues suggest early bacteria were photosynthesizing and pumping out oxygen hundreds of millions of years before then. Where was it all going? Something was holding back oxygen's rise. A new interpretation of rocks billions of years old finds volcanic gases are the likely culprits. The study led by the University of Washington was published in June in the open-access journal Nature Communications. This study revives a classic hypothesis for the evolution of atmospheric oxygen, said lead author Shintaro Kadoya, a UW postdoctoral researcher in Earth and Space Sciences. The data demonstrates that an evolution of the mantle of the Earth could control an evolution of the atmosphere of the Earth, and possibly an evolution of life. Multicellular life needs a concentrated supply of oxygen, so the accumulation of oxygen is key to the evolution of oxygen breathingly. If changes in the mantle controlled atmospheric oxygen, as this study suggests, the mantle might ultimately set a tempo of the evolution of life, Kadoya said. The new work builds on a 2019 paper that found the early Earth's mantle was far less oxidized, or contained more substances that can react with oxygen, than the modern mantle. That study of ancient volcanic rocks, up to 3.55 billion years old, were collected from sites that included South Africa and Canada. Advertisement Robert Nicklas at Scripps Institution of Oceanography, Igor Puchtel at the University of Maryland, and Ariel Anbar at Arizona State University are among the authors of the 2019 study. They are also co-authors of the new paper, looking at how changes in the mantle influenced the volcanic gases that escaped to the surface. The Archean Eon, when only microbial life was widespread on Earth, was more volcanically active than today. Some of those gases react with oxygen, or oxidize, to form other compounds. This happens because oxygen tends to be hungry for electrons, so any atom with one or two loosely held electrons reacts with it. For instance, hydrogen released by a volcano combines with any free oxygen, removing that oxygen from the atmosphere. The chemical makeup of Earth's mantle, or softer layer of rock below the Earth's crust, ultimately controls the types of molten rock and gases coming from volcanoes. A less oxidized early mantle would produce more of the gases like hydrogen that combine with free oxygen. The 2019 paper shows that the mantle became gradually more oxidized from 3.5 billion years ago to today. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new science inventions in future.